Here we go. All right. Hello, everybody. Hopefully you're hearing us fine. I just started the webinar. A few of us have been here kind of getting our act together. So let me introduce our guest speaker today. Dr. Jeff Burgdorf is a research associate professor at Northwestern University. He's also the associate director of the Falk Center for Molecular Therapeutics at Northwestern. His research focuses on how the brain generates emotion and how this knowledge can be used to create better therapeutics for mood disorders. He, much earlier in his career, was a graduate student of the famous Jaak Panksepp, the founder of affective neuroscience, and he was involved in the discovery of rat play through rat laughter. Using that model, he discovered the novel biochemistry of positive affect, which has led to the development of novel therapeutics for mood disorders. And Stuart Brown, Dr. Brown, the founder of the Institute, has a personal relationship with Jeff that he'd like to talk about here.
Well, thank you, Tony. Tony's the executive director of the National Institute for Play and has certainly added a great deal to the substance for those of you who are scholars who want to look a bit beyond the norm. But I'd like to talk a little bit about what Jeff and Jaak Panksepp have meant to me as a physician psychiatrist originally interested only in human play and not thinking a whole lot about rats and rat play. And yet what Jeff has done on building on the shoulders of some greats like Jaak is bring the understanding of play, certainly the evolutionary biology of play, into alliance with human play. And part of the joy that I've had in anticipating today's session is to begin to see that there is a parallelism between rats, which we're certainly not in the subways of New York at night, but there is still a mammalian parallelism between social joy in rat play and social joy in human play. So Jeff, you're off and running. Good luck and thanks for all the pioneering work you've done.
Yeah, thank you. Thank you so much. I'm really excited to give a talk to you guys and learn together about play. So I can try to share my screen here.
Okay.
So let's do it that way. So share. So let me go pull up my first slide here. Rules of emotion. There we go. Here's my slide deck. All right. So in the 20 years that I've been studying play, starting out with Jaak as his graduate student, we've been able to identify the real 10 rules of emotion and how they're important for our well-being and for psychopathology. And each of these is animated, so I'll go through them one at a time. So the first rule is here, is that positive affect follows the seeking system. So you have energy during the day. So the sun comes out, you're energized, you want to go out and explore the world. And that's the fundamental rhythm that play rides on top of. It's daytime, let's go do something. The next part is during that day, what are you going to do? And play is a fundamental part of mammalian biology. It's what animals do, including us, during the day. We want to play. So during the day, we should play here. And it should be coordinated and active. It doesn't have to be social, and we'll get into that a little bit later. But that's sort of the rules. This is what we're supposed to be doing. A good analogy is you can have an 8-year-old kid or a 10-year-old kid in the summer during summer vacation. What should they do during the day? They should play. So the third rule of emotion is at night, you should be sleeping and not playing and not active. And it's really the circadian biology that's the driver. So there's multiple layers. So and this is an emergent property of fundamental biology. First, you're active during the day. And then on top of that activity, you have a certain kind of activity of play. And then at night, you show these, you're asleep. And you'll see these brain rhythms follow this very quickly. Negative affect, on the other hand, tends to be when we're engaged in phase inappropriate behavior. So instead of sleeping, you're awake, and you can't go to sleep. An easy analogy that we all can grasp is it's 4 o'clock in the morning. You're laying in bed. You've been trying to sleep for 4 hours. Are the thoughts you're having good thoughts or bad thoughts? Right? We all know those aren't the good thoughts. And this is sort of what drives that. And you'll see that sleep and wake drive these emotional states. The fifth rule is, while positive affect is easy to elicit, negative affect actually is weighed more. So in the balancing of figuring out if something's good or bad, you need 5 positive affective experiences to weigh out 1 negative affective experience. Now let's move on to the sort of the science of positive affect. Positive affect tends to be normally distributed, which means that the brain wants to have a homeostatic set point where you have some, not too much, not too little. You want to be in the middle of this bell-shaped curve. A good analogy of that would be, for positive affect, a good comic can make you laugh. A better comic can make you laugh more. And this is sort of the rules of positive affect, whereas negative affect follows this other distribution, the passant distribution, which looks like a steep cliff, which is all disease, we'll see in a couple of slides, tends to follow this logarithmic decay passant distribution. So this means that the brain during negative affect can't control itself very well. The example back to laughter and crying is, well, although it's easy to get people to laugh, and a better joke can make people laugh more, it's very difficult to get people to cry. And it's not a movie to make people cry. And you wouldn't tend to get either people to cry a little bit or a little bit more. Either they're going to cry a lot and not be controlled, or cry very little or none. We'll get to this later. A lot of scientific inspiration comes from play, and I get a lot of my insights from literature, which I think is a playful activity. And these 2 rules of the passant distribution and the bell curve really come from my reading of Pynchon's Gravity's Rainbow, where he was able to describe these 2 distributions. The passant, the bell-shaped curve is the good distribution, and the passant distribution is the bad. So very quickly, when you're playing, you're able to see associations and analogies, make analogies, and make similes. And it's these sorts of analogies and similes where new ideas come from. And those are something that occur during play. All right. The next rule is that emotion is in the eye of the beholder. So positive and negative emotion aren't out in the world. It's our interpretation of the world and our internal state that is the driver of emotion. So it's our internal state that is the driver. So if you're in a good mood and you're well slept, and someone invites you to play, you will want to play. But maybe if you're in not a good space, then that same invitation to play can seem to be aversive. and not as positive. The next rule is that it's really chronic sleep deprivation and chronic disease leads to a flattening of the circadian rhythm. So you're not active during the day, and you're not sleeping well at night. And then this sort of creates a chronic malaise. So where your brain and your body are not functioning well. And this is a real indicator of chronic disease. I set up the problems to show you solutions. I'm a person that develops therapeutics and diagnostics. So the solution to this, very similar to what we can think of as a child. It's good to think about emotions as how you would interact with a small child, or an animal like a dog. If you want to sleep well at night, play during the day. So get your energy out, and then you'll sleep better at night. And that's sort of the last of the rules here, is really these two parts of the rhythms go hand in hand. If you sleep well at night, you'll have energy to play during the day. And if you play during the day, you'll be able to sleep at night. So these are very simple first principle rules of emotion. So the next part is Jaak and I have had a very large laboratory of animals, of rats, for 30 years. And I've gotten very good, because it's my job, and I like to be nice to the animals, of figuring out what makes the animals happy. How can I optimize their well-being? It's good for me, it's good for the data, it's good for everybody. Laboratory animals tend to be very happy, by the way. But here's sort of the secret sauce. They live in a controlled environment with not a lot of external noise, a good circadian rhythm for sleep. They have controlled temperature and enough room and enough food. And importantly, they have someone that they can play with. And this is both the easiest and the hardest thing. So the key is we'll be able to see they have to be able to choose who they're going to be able to play with, and those tend to be peer relationships. So they tend to be other animals about the same size as them, and also want to play. And they have to know the rules of play, which we're going to be getting into shortly. Social play requires that both partners are in tuned and engaged with the other person. So they know, and they follow the signals when it's time to play, when it's time to take a break. Very similar to conversation. So the science of conversation, right, is that you have to follow for when people are talking, and when the other person wants to talk, you need to be able to follow that. And both people need to be talking in the dyad about the same amount of time, and that has to be monitored and done socially. You have to be able to pick up on those cues. So we'll get into that in a little bit. And as I was mentioning at the beginning of this talk, I'm actually very interested in finding non-social ways that we can play, and I think that that's what's going to be the innovation in the field. Once we can figure those out. All right, so now I have a video, and I'm going to play it for you. I might have to voice over some of the laughter, so you'll hear me laughing like a rat. So this is what Jaak and I discovered in 1997, rough and tumble play in laboratory rats. This is my hand, which I'll be showing you here in a minute, and what the tickling stimulation looks like. So you won't be able to hear, but I'll voice over the parts for you. Okay. So here's the rat, and now I'm playing with it, very much the same way that you would play with a dog or with a child. And this animal enjoys it very much. And he runs to my hand. And he keeps on running to my hand. He chooses to play with me. And he keeps on running. Like to be able to relate to them. Where did Mr. Hand go? Come on, I want to play with you some more. Why'd you leave? Yeah, so the rats will want to play with me more than I will. And I see this when I first saw this, when Jaak and I first discovered this, I said, oh, I'm going to develop some therapeutics for for depression and anxiety, which we've done. But what I see now, 20 years later, is kind of a rule of emotion. When the animal is ready, it's the right time of day, and it's well fed, and it's in a comfortable environment, and it's ready to engage in social interaction, it's going to do that. It's going to play, right? You can go into a playground and listen to the laughter and the play. No one has to teach them. That's just what biology does. And Jaak had this great quote, and we've done a lot of science on this, that play is the fertilizer for the brain. So what we found is that when you're playing, the synaptic connections are growing. Growth factors are being released in the brain to make more connections. You're more engaged and more attentive.
So, Jeff, can I ask a question at this point? So,
Please.
when we talked in preparation for this session, one of my takeaways from our call was that, and that the name of the actual session is that your brain on play is, firing on all cylinders. Your brain is at its best. Is what you were just saying what you mean by that? That you're creating the plasticity and the growth factors?
Yes, at the biochemical level. I'll show that at biochemical and learning as well as psychopathology levels. Yes, so essentially, sort of to recap a little bit, right? So during the day, you're active. And there's this rhythm of activity. It's the same rhythm of play. And actually what's happening at the synapse is your brain is actually encoding at this rhythm. You're going at this fast rhythm. The animal's vocalizing at this rhythm. We'll see this at the next slide. But what's really happening in the brain is this is the rhythm that allows your brain to take in new information. You're taking in new information and making decisions. Yeah, so this is kind of like the analog input for learning and memory. So perfect. All right, so couple more videos. So here I'm stimulating the brain at alpha, and you'll be able to see this fast rhythm, which I'm going to tell you about in a minute. Again, this comes from the absolute basic science of learning. So learning, we'll get to this in a couple of slides. The fundamental physiology is something called long-term potentiation. So you can get two neurons to connect. So this is Donald Hebb's statement: neurons that fire together wire together. So they fire and wire together at a very particular rhythm. So the brain is waiting for this rhythm, and when it sees that rhythm, it's attending. So here I'm stimulating the brain at this rhythm, and you'll see the animal is walking around and exploring, sniffing, same rhythm, sniffing and exploring their environment. So this animal is learning and engaged in the world. Also making some of these ultrasonic vocalizations as well. So anyone that's done dog training would know that if you can get the animal or the person interested and excited and focused, you can teach them. So this is an animal that I can then teach, and that will be receptive and can learn. Whereas there's the other rhythm, the sleep rhythm, the 20 kilohertz rhythm in the next slide, is associated with negative affect. You won't be able to hear it, and it's probably a good thing. You can probably see that the animal's making these aversive calls. Okay? And then these calls are related to negative affective states. And so this actually, we'll get to this in science, is sort of a paradox that negative affect, your brain looks like it's sleeping. It's not consolidating. It's not taking in new information. The best example of this comes from early animal models, psychophysiology of depression called learned helplessness. It's a very simple experiment where you take an animal that's in a depressive state, you put them in a box, but then you open the door, and the depressed animal doesn't notice the door is opened. So it's sort of gone internal and is not looking in its environment, whereas alpha and this other stimulation is taking in new information. Whereas these rhythms tend to be about forgetting and encoding what's already happened.
So, Jeff, it sounds like what you just described is sort of when I fall asleep in my recliner at night and my wife tries to get me to go to bed and I just don't respond. Is that similar?
Yeah, that's absolutely similar. Yeah, and these things tend to ride on top of each other. This is something that Jaak would really like. Think about it across evolution. The first thing that happened in evolution was seeking, and then circadianicity. You can seek and forage during the day and sleep at night, and then on top of that, positive affect and play became an ornamentation that occurs during the seeking system. So when you don't have that seeking system and aren't engaged, exactly what you said happens. But there's a good side to forgetting and sleep. I always like to say this with when I teach. So if I get the math correct, I might get the math wrong, but I've been alive maybe 40,000 days. Many of us have. How many of those days do we remember in its entirety? Very little, right? And that's important because we have to acquire information during the day and then at night figure out the important parts and let the unimportant parts go away. So we just remember certain things, right? So they have their different phases. So when you're trying to learn, during the day, that's good. But when you shift it, that's bad. So we won't be able to quite hear this, but if you just look at human laughter and human crying, you get these very same rhythms, these fast and slow rhythms. And actually, it's actually kind of ingenious as an engineer. The syllables that I'm speaking at, the rate of the syllables, the rate that I'm talking at right now is this same alpha rhythm. And then your attention is capturing at this rhythm. And if I was to speak at a delta rhythm, it would be disruptive and you wouldn't be able to attend. So this is really sort of the rhythm that we talk and the rhythm that we speak at are directly related to how we learn and how we pay attention. So it's really the bit rate of information from a computer analogy.
So what's the crying part? I'm not following the crying part.
Sure. The crying part is at this slower delta rhythm. I'll give you the example. So the laughter is staccato, chirp, 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 chirp. Whereas the crying and the delta rhythm, when you hear it, it sounds like a siren or a fire alarm.
Okay.
And actually, it's interesting if you just play these same frequencies to the brain with electrical stimulation, that lower frequency induces forgetting, long-term depression, long-term depolarization, or long-term depression of synaptic strength. So it induces literally at the synaptic level forgetting, whereas the fast rhythm is for entraining.
We have a question on crying. Is somebody asks about says that they and some other people in their circles have trouble crying, being able to cry. Is that related here at all?
Yeah, yeah, I think it is. I think that was on my first, something that I talked to on the first slide, that negative affect is not very predictable. It tends to be it tends to follow this Poisson distribution, which means you usually don't show any, and then it's uncontrollable, right? It's sort of like the dose response of getting upset with something, right? It's you go from not being upset to being upset, and then having a difficulty sort of going back.
So
Yeah,
people who don't cry or can't cry can't get past that first hurdle that you mentioned.
yeah. The thresholds have somehow changed in people, and these are things that also these emotional states also change with aging as well. But yeah, that's just part of the biology. It's negative affect doesn't play by the rules like positive affect does, and that's the scary part of it. Yeah.
And how?
And how? Yeah, yeah, yeah. So that was a good question. So okay, okay. So let's move on. Go
Uh,
ahead, please.
Maybe another related question is about naps. Can you talk about naps with regard to the rhythm the rhythms is, do you
Yeah, absolutely.
switch
Yeah,
rhythms when you take a nap?
absolutely. Absolutely, you do. And naps are kind of a difficult thing. It's obviously better to sleep during the day, during at night, and then be active during the day. But what do we do, sort of therapeutically? And I think one of the things that you can learn from this. I used to have a slide for this where you see, and it's really, this is something that we learn from our parents, or we can see in toddlers. A cranky toddler is often told by their parent or their caregiver to take a nap. And a lot of times, these rules of emotion are sort of, the rules of emotion that haven't changed that much from preschool. So yeah, that's a tool that you have. When you're experiencing a lot of negative affect or having a hard time, being able to realize if I take a nap or I prioritize sleep, and I engage in some sleep hygiene, I can help. Yeah, that's a tool that you have.
Well, this is why the presence of play during the day at all ages, so you sleep better, is fundamental to our biorhythms. So I really appreciate your getting the contrast for all of us. Healthier ways of living require play.
And
Absolutely.
ties in with another point from the audience, which is that kids really need to find joy and get rest, so that when they get to school, they're not going to school tired.
Yeah.
Right.
Yeah.
Another angle on why kids need more time to play, free play. Anyway, thank you. Keep going.
And we'll see this. Go ahead. All right. No, great. And we'll see that in a little bit when we look at affect in children, right? We all know that you need to be attentive to be able to learn, and play provides that, because it is the rhythm of learning. Oh, sorry. Let's go. Okay. So now we do some deep dive into some science. So I'm a big data scientist. Just to give you kind of a feeling, some other things that I've done, I've taken 6 drugs into clinical trials, and I'll do things in animals, and then I'll do a human experiment, and I'll try to take that to an FDA approval or a wearable device. So let's look at the fundamental biology. What does your brain look like? And what does attention in your brain look like? Or what does sleep and wake look like? How does the brain work? So let's look at the left-hand graph here. So you don't have to worry about this. Is your brain activity that's called EEG, and then these frequencies, hertz. So really, you should look at the wake EEG. This is the best publicly available data set. And you see this little bump here. And that's at this alpha frequency, this fast frequency of play. And then during non-REM sleep, non-REM 4, which is deep sleep, you don't have that peak. So the change score here is really the difference between them. So you see when you're awake, you're showing this rhythm, this fast rhythm, which either can be demonstrated through the speed of thought or the speed of speech or the speed of encoding by reading or the speed of play. And then we go over to my friends, Joseph Picone at the Temple University Corpus has probably the best big data EEG data set. And what he finds is that normal EEG during the day, just like we saw at wake, you have this really nice peak at alpha, a little bit of beta here too. Whereas people who have abnormal EEG, so when we use the words, there's something wrong with someone's brain, this is what we mean, that when they're awake, they're not showing this attentive rhythm in the brain.
And is that depression? Is that a sign of depression?
Yeah, and we're going to get into that in a minute. That's a sign of depression and malaise and predicts lots of different disorders. So this is when a neurologist says there's something wrong with your brain, that's what they mean. So it's this rhythm of play and engagement that's lacking. And luckily, we can add that back. There's ways of getting at that. So, you can get this with play out of everything that I've tested in animals and a little bit in humans. Play is the best way of facilitating this rhythm and this activity. So this gets us to synaptic plasticity and exactly how that works in the brain. So here, when you have this slower rhythm that occurs during sleep is for forgetting, you produce less synaptic connections. The neurons are less connected. Whereas during positive affect and play and attention, you have long-term potentiation. More synapses are connected. So neurons are firing together and wiring together, and you're learning things. This really is the fundamental biology of learning and memory, and now for emotion.
So Tony, that's and part of lighting up the brain through play. You got it. Big synaptic connections.
That is exactly right. So during play, your synapses are connecting. You're making more synapses. You're releasing growth factors into the brain to make more connections. And then at night, you consolidate that and get rid of the least important information, right? If we remembered, back to my analogy, if we remembered every detail of all 30,000 days that I've lived, our brains would be messy. Right? That's a science fiction experiment I probably don't want to do. We have to focus, and play allows you to do that. So I'm going to zoom in here because I'm a neurobiologist. I'm going to look at individual neurons firing in the brain. So imagine I had a microscope and I zoomed into a certain neuron. So as an electrophysiologist, I can do this. And this is the waveform of the individual neurons firing. There's different kinds of neurons. There's primary neurons, which make the connections and where the learning occurs. And there's other neurons called interneurons. And what we find is that when these primary neurons are activated and making connections, they're showing this rhythm. And this is the rhythm that they fire at. So the activated neuron, when it's learning, is firing at the same rhythm, the same alpha rhythm. And the inactivated neurons are the delta rhythm. So I'm able to take it both from behavior to gross physiology of looking at your behavior and your EMG, your electrical activity in your muscles and your brain, and zoom in to individual neurons. And I see this at all levels. And this is kind of how biology works. It solves the problem. It creates the solution that occurs at the level of the individual neurons are then used and built upon with other sorts of with more complicated behaviors. Again, during the day, first you're awake, then you're awake with play, and then you're learning. That's how evolution builds on top of each other itself.
Let me ask a question here from a physics teacher. He's asking if are you saying that he should start his classes with music with the right frequencies to get the students ready to learn?
Yes, and that's my next slide, actually. Yeah, music works very well, and you entrain to these rhythms. You play music, and your feet taps to the music, and your brain goes to the same the same rhythm. Yeah. Kind of an issue with play, and we'll get into this a little bit later, is it's best. Music produces positive affect very well and can induce dancing, which is certainly a form of play, but you have to self-select the music, and that tends to be an issue. But yes, inducing these rhythms will induce attention and
sub-selecting the music, is that related to what we at the Institute talk about a lot, which is that everybody has unique triggers for play. So some music would get me engaged and in alpha, and some music would not. Is that consistent with what you've been saying?
Yeah. So there's the two parts. It's the right music for you, but it's also the right time for music for you, right? And that's part of the opt-in, opt-out thing, right? A good example that Jaak would like to use would be satiety deprivation function. Play follows that, right? When you're and there's food and an ice cream sundae can be very appetizing unless you just ate 4 of them. Right? So it all depends on the time of day.
Or on the curve.
Yeah, depending on where you are on the curve and how that resets, right? So we play, and then we move to something else, and we take a break, and then we play again. Yeah, and that's the life of the animal. So what I can then do is I can stimulate the brain at these rhythms, and then I can pick up those rhythms through some piezoelectric film or through a microphone, so I can be able to sense these and put these into a wearable device, which I'll talk about a little bit later to be able to pick up on this device. To skip ahead a bit, if we can see, are you really engaged in a playful behavior, or are you in an optimal function, you should be able to see these rhythms in your brain and in your speech and in your movement. And you can pick these things up with devices. So now on to sort of an innovation that Jaak and I were able to discover right before he passed. Initially, we could only look at play for 30 minutes at a time because that was the equipment that we had. But computers got faster, so we can actually record the animal in their cage for weeks at a time. And we sort of follow this rhythm, which I'll show you on the top screen here. So the animals sleep, they wake up, they start to play, and then play goes from a repetitive part of chasing to pinning behavior and prolonged physical touch, at which point usually the play stops at a certain point. And a good play pair will stop before the other person gets upset. A science, the science of play is that as long as both people get to opt in and opt out, and are interactive, that should be they should be good. And play, if one animal keeps on wanting to play and the other one doesn't, then you can induce sort of negative affect. And we can measure this here here on this left-hand panel, we can look at the rates of these vocalizations across the day. Animals, rats are diurnal, so they play at night. So as soon as the lights go off, they start to play. And then they take a break, and then they play some more. I cut off the graph. They'll have another play bout. But they play a lot of the time during the day. I mean, during their active phase. They'll usually play for an hour, 15, 30 minutes, and then take a little bit of a break and then play again. But then at night, they should slow down. And these things, they tend to relate to the activity. So first, they have activity. They want to move more. And then they play. And this shows to be also related to the EEG, but there's a deficit that's seen across aging. So the older animals don't play as much, but we have a solution for them on the next slide. We can do play therapy. So I can use our tickling algorithm or our tickling stimulation. It works very well for the 3-month-old animals, a young adult male rat, and a 29-month-old animal is a very old animal. But what you can see is that if you're patient and you're slow and methodical, you can eventually get some of the older animals to play as well as the younger animals. But in something that I do in drug development, something we're obsessed with, are dose and dose interval and intensity, right? So play at aging might not be as intense and might require more of a break. But it's just as important, if not more important, which we'll see in some subsequent slides. So let's talk a little bit about the science of positive affect. Daniel Kahneman won the Nobel Prize in economics, and then really focused on studying the human side of the science of positive affect. So I was able to really take what he did in humans and show it in animals. And what we find is we can take the social out for now, but really positive affect and play tends to be an active behavior and not passive. So this next slide we'll really spend quite a bit of time on. This is really a summary of the hard data in positive affect. So this is both by Daniel Kahneman and Stone on the left-hand side and Csikszentmihalyi. So on the left is in adults and the right is in children. So what induces positive affect in humans? So what we find is that things like socializing is very, very good for inducing positive affect, but depends on what kind of socializing, right? A lot of people don't like working and socializing or talking on the phone. That's less positive. Certain kinds of social activities are good as well. I'm going to skip over the TV for a second, and I'm going to shift computer internet. This tends to be a very consistent finding here in adults, and then over here with TV in children. That sort of passively taking in vegetable video tends not to induce positive affect. So if you're not engaged in the content, it tends not to really induce positive affect very much at all. And then really another thing that comes out of these data sets is it tends to be peer-peer interactions, your friends, whereas doing things with your coworkers or your boss tends to be less negative, produce positive affect. And in children, it's the same, right? It's not talking, it's not TV, it's talking to your friends that is inducing this. And then, of course, out of all the data, play and going to the playground is the best inducer of positive affect. And one of my favorite vignettes in the science of affect and the science of play comes from Csikszentmihalyi, the person that did this research, famous for the flow experience. He noticed this and he asked the children, he said, you spend a lot more time, this is time, watching TV, which does nothing for your positive affect. It's neutral. But, if you went to the playground, you would, have a lot more positive affect. And what the kids would say is, yes, you're right. I would be happier if I went to the playground. But I'd have to get on my bike, and then I'd have to go and ride my bike to the playground, and I have to make sure my friends are there, and I have to call them. Right? And I think that's a really important thing that comes out of this. Like exercise, play something that's good for you, but you kind of have to prioritize that, which is kind of a little counterintuitive for something that, induces positive affect. Positive affect really isn't that good of a driver of behavior. We need to spend more time doing that, like engaging in self-care behavior. But the more time we do that, the more our brain and our relationship and our body benefit from it.
Let me ask, we're getting a lot of questions here. Here's one that seems to be pertinent now is, could we make a statement, or would it be possible to come up with almost a formula that brain stimulation, that learning, with regard to brain stimulation, that learning is X times better or X times more optimized if it's done through play?
Yeah, that's a great point. Yeah, because I bet you it would be more effective to be able to get people to learn better, to get them engaged and excited. Yeah, that would work better through play. How we would quantify that scientifically is something that I think is the cutting edge that I'm trying to get to.
Okay.
Yeah.
Jeff, is there not a greater payoff if the activity and the rhythms of play are personalized preschool, when there's rapid brain development going on and the socialization is in its learning phases, so that assuring the preschool years establish play habits and learning and curiosity is a fundamental priority of human beings worldwide. What do you?
Go ahead.
That makes sense?
Absolutely. And I think especially for this generation of children, there's there's a pandemic of depression and suicidality in children. In part because they're essentially play deprived and they're sleep deprived. The nice thing about social interaction is it's all wired for that. We'll play for a while and then it's time to go take a nap. It's time to go do the next thing. Whereas, when we're engaging in the digital world, it doesn't really do that very well. The couple of things that end up happening a lot of times is that, if we're just two people playing, we'll eventually get tired and go to bed. But if you're with your device, you can watch your device all night, right? And, the kind of friendships that you develop. Go ahead.
Well, this is monumentally important work. I hope you feel good about it.
Yeah, no, I certainly do. Yeah. So you need to play, and it's not just a good idea. It's really what your body's supposed to do. and as I'm going to be moving into some psychopathology, the closest that we can come to regularized play as adults or socialized activity is something like psychotherapy. It's a bit of a stretch, but stick with me a little bit. It's socialized, it's opt-in, it's verbal, which a lot of play is verbal, or a lot of social interaction is verbal, and it's well controlled, that the person on the other end isn't being a bully. They're listening. Cardinal rule of therapy is don't give advice and listen. So the cadence of talking and listening are controlled. So it's a really good controlled social situation. So let's just, before we go into the psychopathology, let's just look at the rhythm of affect again. So this is both in humans and in animals. It tends to show a bell-shaped curve that you wake up, you're a little groggy, and then sometime in the late afternoon, you sort of peak, and then 6, 7, 8 o'clock at night, you start to get tired and go to sleep eventually. Whereas negative affect is an error function. You're not supposed to have them, but you have negative affect when you're not obeying this rhythm, when you're staying up too late and you're not sleeping. Right? The best way of inducing negative affect in people and animals is to chronically sleep deprive them. And we'll see that in the clinical data set as well. Where you're supposed to have these rhythms, right? If you tie to we've all had this experience probably as a toddler. We can relate to them, being very excited at 6 o'clock in the morning and going to your parents and wanting to wake them up. It's Saturday morning. Let's go play. And you might have the enthusiasm, but maybe your parents want to nap still, right? And a lot of negative affect in animals comes from this dichotomy. One wants to play, one wants to sleep. And if their rhythm is synchronized, they have good positive affect. But if it's asynchronized, then that's where the negative affect comes, where one wants to sleep and one wants to play. All right, now we'll shift over to a problem that we were able to solve in the world of depression. So let's dig in. I'm a hard data guy, so let's look at some hard data. So this is an FDA approval study. So this drug, zuranolone, was FDA approved for the treatment of postpartum depression. And this study that I'm showing you right here was the study that the FDA used to make that decision. And what you can see on the y-axis is Hamilton Depression Rating Scale. This is the way of looking at depression. And then what you see here is the placebo group in the gray. You get a decrease, a very rapid decrease in depression over time. By about 18 days after the start of the experiment, the subjects are back to normal. Whereas with drug, they also go back to normal very quickly. But in day 3 and day 8 and day 12, they show a little bit faster return to baseline. So really, this has been a problem in depression research and has been really real disservice to the patients and the providers. What this is really saying is, well, if you're depressed, you'll feel better. Take 2 aspirin and call me in the morning. You'll feel better more quickly. And that's really not the case for a lot of people. But this is what the data looks like. So what ends up happening is a lot of times you can have a treatment and it seems like you're doing better, but you could just be doing better by chance. And what we found with the big data is a lot of depression works this way, but it doesn't capture the severe depressed people, the people that we know that have a severe problem. They get noised out by this group. So we're going to look at that in the next slide. So luckily, I have access to these large human databases. So this is the NeuroBlue database, 36 million de-identified patients. And then we can look at depression across time. So the first thing that we learn, Jaak, I think, would really like this, is how important emotional self-report is. You need to realize if you're sad and have a lot of negative affect, that's a good thing because you'll be aware of it and you'll be able to solve the problem. Whereas the people that don't have that insight, that right before they get the depression diagnosis, you ask them on a scale of 1 to 10, how depressed are you? The people that say they're not depressed, the people that don't have that insight, these are the people that need the most help. So to have the feelings help you make it better. A sort of an example, we're getting into addiction here in a little bit, is the cardinal rule or the first tenet of Alcoholics Anonymous: admit that you have a problem, right? You have to first know that you have a problem before you can fix it. And what you see in this big data is the people that say, I have a problem, let's fix it, have really good outcomes. So the next panel here is what depression in chronic patients, about 5% of subjects, looks like over time. This is years that I'm able to measure. So I don't know, maybe after about 5 years, we have some problem with the data and it tails off, but it tends to be stable across those first 5 years. And I'm very proud of the fact that we're finally able to see a gender difference. We've been looking in the field for a difference between males and females for a very long time. And we needed these large data sets to see them. So 70% of this group are women. And you see that the women tend to have a longer depression episodes. Next, something that's not the greatest thing, but people that have unhappy marriages tend to have longer, more persistent depression. People that are sort of stuck and can't get out. People that are, don't have the ability to move. Also have this. This is not saying that the marriage is obviously a good thing for many people, but what this is saying is you can't just say, play, go socialize more. It needs to be with the right people. You need to be able to choose. It's not all socialization. It's the ones that you get to opt into. And then kind of a surprising thing is a time course across age at first onset, whereas the teens and the 20-year-olds tend to have a quicker resolution of depressive symptoms. Whereas if you get into these 40, 50, and 60-year-olds, they tend to get more depressed and stay more depressed longer. So, that seems to be very important. As if you remember from the last graph, there's a dose response or a time course or an age-dependent effect with play. So we lose play with aging, but we can restore it. It's harder for us to do that, but we can do that, and we need to do that. It's the same way when you age, you get less steps, but you need to make sure to get your steps. Then it's actually enjoyable to get steps.
Let me interrupt for a second here, Jeff. We're approaching an hour, but I think we're going to just keep going. So hopefully those of you can will stay with us. We'll answer some questions. Jeff's just got a couple of slides left. And if you have to go, there will be a recording of this on the front page of our website within a week. So back to it, Jeff.
Great. I was a little chattier than usual. Yeah, only a couple more slides left here.
Fantastic stuff. That is not a negative comment. We're happy.
Very good. So let's zoom in. Let's zoom into this severe depression. So and let's stick with the left-hand panel, which is the effect of age. So in aging from 20s to the 70s, there's a change in this abnormal EEG, which we learned early on. That's the lack of alpha during the day. So you see that you have less of this alpha, this play state in the brain, and less sleep, and an increase in chronic depression. And what we see then as psychotherapy, which is my index in big data, I don't have a lot of great indexes for these, of seeking social help. The middle panel I'm very interested in because you can see a dose response across disease severity. So you can see the controls, single episode depression, chronic depression, people that have suicide attempt, suicide completers, and then people in end-stage palliative care. And you can see that this alpha EEG with abnormal EEG decreases across these groups. And insomnia is a little weird. I think it also increases as well. I have to check on that data. But what we see is that a lot of times, whereas the good chronic depressed patients will seek psychotherapy, whereas the people that don't seek help have a worse problem. And, one of the saddest things here is that the biggest difference between the suicide attempt and the completers is the attempters, they're not seeking out psychotherapy, and they're engaging in psychoactive drug abuse. This is clinical drug abuse, right? And that's clouding their decisions and taking them from someone that's going to be depressed but be able to talk through it to, in a drug-induced state, having a permanent solution to a temporary problem. This is really important at this time, and we'll see this in a couple of other slides. I'm able to then see these same effects in these large data sets. The STAR-D data set is the largest ever controlled randomized study for depression, to see what if you could then take patients and then treat them with multiple regimes of antidepressants, which patients respond. It's the same ones. The patients that have the problem with sleep, that are older, that show insomnia, that are sort of stuck in life, have these problems. And a very quick little mini pitch. I also do artificial intelligence. I'm using an explainable artificial intelligence way. You don't need to just put everything into the computer and give it the answer. You should, in your mind, be able to see what the computer's doing. And this is really the cutting edge thinking in AI. So okay, then really sort of the next one is my last real data slide. And then I have a conclusion slide. So the solution, play, sleep, is important. So our surrogate for play is psychotherapy. It's the best we can do right now. And you can see that the people that don't get psychotherapy, they get worse, stay worse. And then there's this trailing phenomenon, whereas the psychotherapy people get quick, very rapidly, you seem. But I want you to zoom into this point right here and remember to not give up. Right? Let's say you've been doing this, because this is a year you've been doing psychotherapy or exercise or trying to lose weight for a year and it hasn't been working, right? And you think it's not been working. Well, one, you don't know your control group. Your control group actually got worse. And just over the hill, you'll see improvements. So these things can work, but they take time. Also, simple things like melatonin, which is kind of our idea of let's improve sleep. This works really well in this group of patients. And then lastly, I have to dial down a little bit from chronic to mild depression. As a pharmacologist, I like to see dose responses and look at different compounds. So Tylenol is my control. No one thinks that should be an antidepressant. Chronic opiate use, bad. I would say across all these disorders, when people start taking chronic opiates, probably because their life is, they have chronic pain, those are related to bad outcomes. Whereas really improving sleep with melatonin or hydrazine, which is a version of Benadryl, which is going to help you with your rhythm, are as good as the antidepressants and psychotherapy. And as you go to the really even more chronic patients, like the ones in the left and right panel, those are the ones that are really preferentially responding to psychotherapy or play or sleep. And then my very last slide is, what is play and how do you get that? How do you get play? And how do we operationally define it? So one thing that's clear is, one, you have to opt into play. You have to decide when you want to come in and out of play. Then it should be an active process and not a passive process, for sure. And then I should be able to, using a wearable device that you can chronically wear, be able to measure this rhythm in your brain and in your body. And it should be fun. It should be fun. It doesn't have to be social, but if social works for you, that's a good thing. But the innovation will be the non-social play. And that's all I had. Thank you very much.
Jeff, we have lots of questions. Stuart, did you go for it?
Well, I think you just got going really full on, and I'm absolutely enchanted by the idea that someone could wear a necklace that is depressed and begin to see that the placebo effect you showed was so effective could be accelerated by their play, which is personally unique to them. So you're on to something that is potentially culture changing, and there are billions and billions of dollars. And I can tell you as a clinician, the angst that one experiences with highly depressed patients, there's a lot of suffering that could be alleviated. So you're not only play, you're on to things that are terribly important and good for you. And I hope we can see you again as our guest. We're very honored to have had you here. And you didn't go over time. We just went under time with some of our technical issues. So thank you.
But no, can you hang for another 10 minutes or so, Jeff?
Yeah, I'm good.
Let's ask some questions. So one question is that assuming neuronal rhythm is important and associated with play, then would playing along with a musical or some rhythmic accompaniment amplify that or make it even better, make the play better?
Absolutely. And, this is something that we're starting to do. We're getting IRB approval now to go into nursing homes and to have singing and sing-along sessions for play. Because what we've been able to show, and using similar sorts of wearable devices. So really sort of the science of music is self-chosen music can induce this play state and play brain rhythms. But if you're actually performing the music, if you're singing along and active, you even get more of a benefit. So yes, this is exactly where we're going with this line of research.
Okay. We're considering the term learning block, where a learning block is a mental or emotional or some obstacle that prevents a person from learning effectively. Is there a correlation between rhythm and learning blocks?
I would definitely think so. I think the ability to play sort of gets you out of that. Something that Jaak used to like to talk about was attention deficit disorder or obsessive compulsive disorder, and that's being different from play. Sort of obsessively being locked into something and not being able to take a step back and look at your environment is not what play is. Play is being able to look around and attend to your environment. And a lot of times that's where the solutions to these blocks are. It's not right in front of your face. And, an example that I like to use sort of humorously, at least to me, is that my passport, when I'm getting ready for an international flight, is not in my freezer, even though I look in my freezer. Right? You have to be open to looking in other places as opposed to just do your compulsion. Yes. So good question.
Another ADHD related question came earlier. Well, when you were talking about negative stimulations triggering forgetting.
Yes.
Like not noticing that the door's open or the dishes need to be washed.
Yeah, that's good.
That seems to match a characteristic of ADHD where you just don't notice and keep passing it by. Is there a connection between ADHD behaviors and play or sleep and appropriate phasing?
Absolutely, absolutely. Yeah, ADHD is, engaging in more of these non-attentive compulsive behaviors. Jaak, if he was here, really loved ADHD. And he always thought that play had a special place as a therapeutic for ADHD. I think it's when you look at these huge data sets, you see things and you can't unsee them. One of the things that you see is just how often and how many kids are taking amphetamine for ADHD and taking a clear drug of abuse repeatedly. And we know that taking drugs of abuse repeatedly are not a good thing. And we know from Jaak's work and my work too that amphetamine reduces play. So essentially, these ADHD therapeutics are amphetamine, literally.
Okay. Back to some of Jaak's work and the seven emotions. Is crying related to the panic or grief emotion?
Yeah, yeah, it is. Jaak used to say and remind us that crying is fundamentally a social thing. Those crying evolved for the child or the person in need to signal socially to someone to take care of them and to help them. It's a cry for help. Yeah, and it's primarily that's its primary function.
So is there a connection there with seeking, sort of the seeking to get soothed? No, or is that seeking?
No, that's an excellent. I never thought about it that way. That's a really good point. You're engaged in something, but it's kind of like the reversal of that. Seeking is you go to something. The best example of sniffing, of seeking in the world that I've ever seen is a dog sniffing and on the trail to go to go chase a bunny. That's the seeking behavior. So it's engaged, moving. Whereas sadness or crying is to stay still and ask for someone to come to you.
Got it. Okay. Here's another question. If alpha rhythms are the foundation for attunement and engagement, and delta rhythms are the rhythms of forgetting, does the rhythm of hypnotic induction resemble delta?
Yeah, I don't know. That's a really good question. Yeah, I don't know. I don't know. There hasn't been that much work on hypnotism in that. I know that people who have deficits in alpha or are more likely to. I think there is a relation. As a mature scientist, I'm going to say I don't know the answer to that question, but it's an interesting one. I should do an experiment on that.
Great. All right.
Good question.
Let us know when you do, and thank you very much. I think
Yes, thank you.
most of the
I
big
got a lot of questions, but I may just pick up the phone and call you.
Yeah, let's have another meeting. That'd be great.
Well,
Thanks
you
again.
Thank you so much, Jeff, and thank you for everybody who hung with us here for an hour and 14 minutes.
Yeah, I'm always anyone. Feel free to reach out to me. I like to engage. Thanks.
Bye.
All right. Bye-bye.